Now, using first principle, find the derivative of y equals to sin x. We want to prove that sin x equals to cos x using first principle. Now, what the first thing to do is that in calculus, when you are using first principle, that means there is a change of length. That means the first thing you do is that y plus change in y, that is change of length, that is y plus dy, equals to sin x plus dx. There is always change in letter, change in length of y, change in length of x. That's the first thing you do. The next thing you do is that you now make dy the subject of formula. That means dy equals to sin, open bracket, x plus dx. Now I'm making dy the subject of formula, so I'm bringing y to the other side, minus y. So the next thing is that dy equals to sin, open bracket, x plus dx minus, I will now input the value of y. What's the value of y? Sin x. Sin x. So after I've done that, what is now the next thing to do? Sorry. I have dy equals to sin x plus dx minus sin x. Now, from our previous videos, if you have watched all these our product formula, you know what I want to. You have to understand what I'm about to do now. If you have not watched it, go and watch it. That will be sin. You will say x plus dx will be our a, and our x equals to our b. So that means I can say sin a plus b, sin a plus b equals to, and what's our sin a plus b? That is sin a cos b plus cos a sin b, and also sin a minus b, that is sin a cos b minus cos a sin b, from our previous videos on the product formula. Now after that, what do we have to do? We subtract. You have to subtract. That means I want to subtract the two. That will be sin a plus b minus sin a minus b. Now if I subtract, that means sin a cos b will cancel sin a cos b when I subtract. But if I subtract, as you know, minus times minus will be plus. If minus times minus is plus, that means our answer will be 2 cos a sin b. Our answer is going to give us 2 cos a sin b when I subtract. Because we subtract, that's why we subtract. Now after that, we need to get the value for a and b. And how do I get the value for a and b? Now go along with me. We know that our a plus b equals to a plus b equals our x plus dx, and our a minus b equals to our x. A plus b equals to x plus dx, and a minus b equals to our x. Now if I add these two together, a plus b plus a minus b, that will be x plus dx plus x. What would that one give me? When I add the two together, x plus dx plus x, it's going to give me now minus b cancel plus b. A plus a, that is 2a, equals to 2x plus dx. That is 2x plus dx. But I'm looking for a anyway. All over 2, all over 2. My a equals to, if I distribute these two under these two, that means if I say 2x all over x plus dx all over 2, then the 2 cancel 2. So I'm going to have x plus dx all over 2. That is my a. Do not forget what this will give us. Give us 2 cos A sine B. Now I need to get my B also. How will I get my B? Do not forget I had it before. I want to subtract it now. That means A plus B minus, open bracket, A minus B equals to x plus dx minus x. Now, you know, A plus B, if I use this minus, open bracket, minus A, minus and minus plus B equals to plus x cancel minus x equals to dx. So that will be minus A cancel plus A. That will be B plus B, that is 2B equals to dx. 2B equals to dx. 2B equals to dx. If I say all over 2, all over 2, that means B equals to dx all over 2. Now B equals to dx all over 2. So we have gotten A, we have gotten B. So we now need to substitute it for A and B here. Now that means we're going to have for here now we are going to have 2 cos, what's our A? Our A is x plus the x all over 2 sine, what's our B? Our B is the x all over 2. Do not forget that is our dy equals to this. Our dy equals to this. Now the next thing we do is that we divide both sides by over dx. All over dx, all over dx. And our dy is this. Now, what's now the next thing to do? After we have done this, the next thing to do now is that if you look at this thing very well, you can also write it like this: dy dx equals to 2 cos, open bracket, x plus dx all over 2 sine dx all over 2 all over dx. See what I want to do with this ds? I'll just say times 2 all over 2. This one is still the same thing, but this 2 will cancel this 2 and it's going to remain dx. Now if you look at this thing very well, this 2 can cancel this 2, and sine dx all over 2 and dx all over 2, this thing is equals to 1. Is equals to 1. How do I know that? Under the standard limit. Under the standard limit. Sorry for that. Under the standard limit, when you have something like this, like sine dx all over 2 all over dx all over 2, we have the same thing here with sine. It's going to be 1 under the standard limit. That's why I know that this one and this one equals to 1. Okay? And I've said that this, don't forget, these 2 cancel these 2. So we have the y, the x equals to cos x plus the x all over 2. Do not forget, when you are doing this, you say the x tends to 0. When the x tends to 0, that means the y, the x equals to cos x plus 0 all over 2. Then the x tends to 0. And after that, that shows that s equals to cos, 0 or divided by 2, that will be 0. X plus 0. X plus 0. That means my dy dx equals to cos x. So that is the answer why we are deriving from sin x to cos x. Thank you.